Hello, good afternoon. Can you hear me fine? Good. So, I will try to give high-level overview of the large, very large domain. So it will be conceptual slide. It will be slide hinting at some ideas, recollecting some elements of my past works and presentation, and at the same time stressing that trustworthiness is probably the most important feature of AI technologies and systems if they survive. So I have deep roots in industry. I have worked for Hewlett-Packard 24 years. I have worked for Energo Invest for 12 years, and I have worked for Consiglio Nazionale della Ricerca in Italy on modeling stuff. I will claim that all technologies surviving long time, they must be, or they should be, trustworthy. Thinking about transportation, thinking about electrification, thinking about communication, all those technologies survived long time based on something which is clear, systems which are operating that you are not aware of it until you have communication breakdown, as yesterday or day before, as you have troubles with eventually traveling somewhere, and then also eventually having some other kind of technology breakdown. I said also that those technologies are invisible, so that's it. And then they are impacting economy, society, and politics. A lot of people look into AI as something which is pretty new. In reality, when you look at this slide from the top right until bottom right, you see evolution from ancient Greek times about automation automata, from Aaron automation, opening door by steam, water distribution or distributor with coins, Da Vinci lion, never really implemented, but others, yes. And Vaucanson, duck, eating and behaving as a real duck. There is a museum in Grenoble where I live of those automatons. Then you have Norbert Wiener, who you should definitely know, playing chess in 50s, somewhere in Paris. Then you have Kasparov, chess, and then Go. So when you look back, technology of augmenting or imitating humans is long present. And it's not probably just a case that subtitle of Turing article is imitation game. So people have been trying to imitate human behaviors for long. Now, here is another slide which goes into particular technologies, which I will not mention or explain. Will point at the line of development from ancient times to modern computation period. And on the right bottom, there is indication from the slide I have used in 2006, that was celebration of 50 years of artificial intelligence in Europe. And this is a big picture into eventual past development and possible future. So what we are hinting here is that embodied intelligence is most likely the future. imitating biological systems, which we currently see, unfortunately, as swarming drones in war operations, in which some of you realize quickly that war, unfortunately, is also a big accelerator of technologies. And in the future, it will be most likely cognitive systems imitating insects as they are longer present on Earth than humans. So it will be good to look, not only to insist on human intelligence, but look what the nature has done with insects. Next one is a reinterpretation of the previous slide, trying to make classification and indicate three layers important for AI system classification, which is mathematically sound. So it's on logic, on heuristics, on statistics or probability, and then certain technologies in a layer above, and ultimately going into application layer, being very diverse. So it will be impossible to give it on this big picture slide. Here is something which is a topic of my talk, which is trust as a human dimension, trust as a problem of human-machine interaction, in which I would claim that at least three separate fields, trust human and human, trust human and machine-to-machine trust, will be three domains to be explored, imitated, and eventually transferred between those three. When you look on the human side, here I'm claiming that privacy and security is important. On machine part, it's reliability and dependability as the two words important for a machine. And then in the bottom, I'm indicating that AI has three ages, which is embryonic AI. It's tick-tock-tack, game playing and other initial programmed AI systems. Second is embedded AI system, which is currently today probably age of embedded AI or AI infusing into anything and everything. And future will be embodied AI. So I'm claiming that investigation of trust is domain which deserve future explorations and research. Here is a slide going a little bit deeper, but not enough to be discussed at all at any detail, but hinting at quantification of trust. Quantification could be done via numerical methods, and outcome would be number, while it could be verbally expressed. And in table on the left side, which I have taken from PhD done in Canada some 30 years ago, you see mapping between numerical range of trust and label or verbal expression of trust, ranging from blind trust +1 to complete distrust -1. Further, I'm indicating that it's a multidimensional entity, that it's difficult to understand fully because it's extremely complex. It's tricky to be captured formally, and clear and crisp mapping of trust into trustworthiness is needed, is not always present. Possible three approaches will be probabilistic, either frequencies or Bayesian, then logic, fuzzy and crisp, and heuristic, trust based on knowledge and experience. Let me mention as well that on each of those slides, which you can later see on a website, you will have URLs on publications from which I have taken those vignettes. These days, it's everywhere. It's ChatGPT. Here is a sketch of architecture in which I'm hinting something which is obvious, that entire techno stack should be trustworthy, from data sources via algorithms to trusted infrastructure. In this slide, I'm also indicating troubles with the ChatGPT, which you are well aware of. Hallucination, which is probably unavoidable. Reason being, while you are training a system on known data, once you go out of this, you have no guarantee that result will be trusted. So universal approximation theorem is a basis for this claim. You can look further. Next thing is poisoning of ChatGPT via prompts. Since you put out of context, out of mind, addition to real prompt, and you get hallucination. So meaning that the system is either lying, either deceiving you or inventing something. So ChatGPT was used even to produce evidence for medical trials. So ChatGPT invented cases on which medical trials ended successfully. So one should be extremely careful about output of something which is present in every domain of our daily lives. Now, in the bottom, I will indicate that you will always make distinction from greenfield or standalone system. You are creating systems from the scratch, which is not so often the case. More often is brownfield. I'm using terminology which is architecture technology for large-scale systems, in which you have to take into account the whole environment and think about trustworthiness in which AI was infused or embedded in system. Then it could be eventually loosely or strongly coupled. And again, you have to take care of this. So at least 3 setups which you should be aware of. As always, system can lie, but you have to be careful what's the risk posed by using output of the system which is not trustworthy. So reading this slide from left to right, I'm claiming that for the high risk situations, trust level will be at that level that system must be certified and regulation should be strict. In the next 2 or 3 slides, I will indicate which exact cases I believe that AI system, whichever configuration, should be certified. Then for systems not posing a great risk, as only lying, you are recognizing lie and you continue, it's just low risk. Those systems should be monitored. Now, in this triangle, risk profile in reality will hint at the required trust level, and regulatory rules should be adapted to this level. This is extremely complex question, still debated, and there is no clear agreement how to do it and what to do it. Typical example is European Union is advocating regulated space. United States is saying, no, let's keep it like it is. Let's don't kill innovation, as an example. Now I will show some works from the past in which more details are, as always, in the URL article being shown here. This one is about corporate security as a trustworthy system in which corporate security is practically morphing into security intelligence. And probably those are systems requiring very high trust level. Important thing here to hint is that those systems can be used for different purposes, for real-time monitoring of situation, or eventually for investigation into past cases, and eventually doing something which is related to investigation in accident in the past. So AI injected here should definitely be trustworthy. The next one is high-frequency trading monitoring cockpit. Cockpit as entity here, I indicate as a kind of interesting thing. I have worked with HP Labs in Palo Alto several years ago on this cockpit concept, which in reality, instead of dashboards, you have closed loop in which people cannot avoid, It's like a pilot. He's in a cockpit, no way to avoid human reaction. So when you have trading desk in which majority of trades is done by high frequency systems competing against human traders, then in a stack on the right side, when you inject AI technologies, you should think about how much money you can lose or you can get. To tell you that once when high frequency trading crashed Wall Street machines, it was like for 20 minutes, close to $1 trillion loss. $900 billion was lost because of this crash. The next one is a poster about cancer advisory AI augmented system, presented at the poster, which was wisely rejected on one IEEE conference in San Francisco, but which indicates something which also require highly trustworthy systems. Imagine what would happen with misdiagnosis caused by AI system. What might be consequence for your insurance, for your bank, for your family, for yourself, etc., etc. So proposing a system which will eventually combine, as you see, which will combine several repositories about individual, hinting at the personal medicine. In reality, is highly delicate for several reasons. And therefore, such kind of systems should be definitely certified. The same system I shown in high frequency domain, in which it must be certified. Otherwise, someone will be in jail, losses. As I titled this talk, Construction, as I have spent last 10 years in HP being architect, I would like to use this word, constructing, into three separate acts: architecting, designing, engineering. Majority of people here are engineering people and design people. But I would assume that some of those are also architects looking into domain as a big landscape. So when you think about defining those three phases, left one will be about only saying conceptually, it's a cloud, it's a fog, which is communication infrastructure, which is edge. On edge, you will have trillions of sensors and billions of devices, as billions of phones, each one being in our pocket, millions of servers and PCs, and who knows how many devices in a fog. You do not put any kind of technology hint, or you do not put vendor's name. Designing means you have to choose technology and vendor. because typically you might be locked by vendor choices and constrained with vendor choice. In that sense, designing, you are disclosing that conceptual architecture, big picture, is becoming named. So you know that it's Microsoft Azure, you know that it's Raspberry at the edge, etc., etc. Once you enter into delicate things, up until now it was all simple and easy. But now start implementation in which you have requirements regarding different things, either being latency, either being space, either being energy, whatever constraint you imagine. Once you enter into this and looking into performances, you are engineering, the most painful part of this journey. Sorry. Now, make things a little bit more complex. Trustworthiness, if you look at the research, is explored in multi-agent systems, in distributed artificial intelligence. And here is only reinterpretation of the previous slide in which I have described what I mean by architecting, what I mean by designing and engineering. Here is a little bit more details. And again, in the table on the right side, I'm hinting that I believe that imitating nature is something which might give important hints for humans. And not only imitating human intelligence, but behaviors of natural world around us. So, for example, insects are much more aware of the climate change, and they know when and how and where to start migration, if you look into this. So, world of nature already has certain solution for certain things which we believe that we understand fully. The next one is a slide which I have published some 6-7 years ago, and it's available on European Commission side on HIPAC Barcelona magazine, and also somewhere on ResearchGate. It's my joint work with Martin Walker. And here we are indicating two worlds which all of you are recognizing. World of simulation and world of analytics, or machine learning workloads being on clouds of Microsoft, Amazon, or whatever, and simulation workloads being on roughly 25 data centers around the world. Now, when you look at the bottom, there is a huge inflow of data from the edge, in which at the end there is a data grid. And each and every piece should have capacities to operate as trustworthy system. A point which I would like to indicate here is in the middle, AI meta broker, which is our thinking that probably when we think about big science means in old terms, big data, big infrastructure, big algorithms, whatever is big, and big science may require this kind of infrastructure. And our thinking is that AI may help in brokering as a broker for hyperscale scientific system, becoming kind of hyperscale scientific instrument never seen before. How we are doing? 7/8. Okay. As I was showing examples of high frequency trading, corporate or enterprise security, medical, about cancer advisor, I was hinting at the certification at the end of the road, meaning that if you want to ensure that you have system which deserves to be widely used and trusted, then you should aim at certification. And table is just visually saying, if you want system to be dependable, then you have to test and verify. Secure, you add validate, and to safe, to certify. And another interpretation below would be verification of data quality, validation of the algorithm correctness, and certification by a regulating authority. And I'm saying this is a three-stage road to certification for safe AI systems. I have one more slide, which is not, it's here. Okay, thank you. Now, this is a slide from my presentation in Berlin, O'Reilly Conference 2000, I believe, 19. Title of my talk was, Can AI Systems Be Trusted? Now, I'm repeating what I was saying at that time, that trust is extremely interesting domain to explore. First, to study, to understand better, then to test, and to come to the level of certification of the top. And then thinking about three levels of trust, being high, medium, or low, then a system must be safe, secure, and robust. Now, some advices coming from things which I have seen in my past. Before deploying any AI system, think about real impact and legal consequences. Second one, holistic, exhaustive testing should be done before deployment. And final advice is certify your AI system. Reason being is also that at the end, as we are seeing AI mania or hyper mania, whatever you take, since it's $3 trillion in play, then if we are in a bubble, a lot of people will lose money. And eventually, when you think about two camps of thinking, one being AI as a replacement technology, replacing humans. Why replace human? We have 8 billion intelligent creatures already, Why to replace them? We can imitate, but not replace them. I'm more on a part as an engineer that AI is augmentation technology, augmenting technology. So augmenting people in a way which is acceptable for the people. At the same time, as several of you here stressed, three principal obstacles will be, which is energy, which is ethics, which is environment. Those three things are somehow anchoring your thinking. Why should I think well about constructing trustworthy AI system? And at the same time, when you take problem which you would like to resolve with AI system eventually, then think about it, that it's not technology looking for the problem, but you look at the problem for which AI will be eventually suitable solution. So with this thing, which is in two lines, architecture, design, and engineering are three phases of constructing, and trustworthiness should be explored further because we are missing measurement, modeling, and certification of those AI systems. With this point, I will stop.
Thank you, Kemal. We do have a time for a quick question. I'm coming over to you, sir. Oh, you got him?
Thanks. That was a great talk. I was struck by something that you said towards the beginning. You said the AIs, if we call them that, the large language models that everyone's very excited about right now, hallucinate as a matter of course, because that is all they do. All they do is autocomplete. and then we add layer and layer of checks and guardrails on top of that. And I was quite struck by that, because how do we get from that to trustworthy? It's so easy to trip them up if there's no guardrail already in place. And you can do this yourself if you just ask one about something that you know about. You can trip it up so easily. How do we get from that to trustworthy? I'd love to hear your thoughts. Thank you.
You know, it's a delicate question, because there are two big camps. One pushing no limits, let's do whatever is possible, and another saying guardrails, we should ensure from our previous experience that we have to put limits. My sense is that depending on domain, application, and potential impact, you should decide, would it be regulated, as I said, strictly regulated or mildly regulated, only monitoring. So considering that establishing a worldwide policy about this is an impossible thing, I believe that it will be very fragmented, and it will be decided regionally different, and eventually at a certain point coming to something which is similar to today's economy. Some parts of economy are highly regulated, some are highly on the loose, so to speak. So my sense is that this might be the outcome. Have I answered your question? Thank you.
Okay, thank you, Kemal.